For this video, we're going to evaluate this integral, the square root of 1 minus the square root of x dx. You want to give this a try? Go ahead and pause the video. I'll be right back. Okay, I'm going to use a U-substitution, standard U-substitution. I'm going to let U equal to what's under the outside radical there, 1 minus the square root of x. So du will equal to, derivative of 1 is 0, and the derivative of minus x minus the square root of x. Think of this as x to the 1/2. Let me write it this way. Use the power rule for derivatives here, so 1/2 times the minus 1 is minus 1/2. Subtract 1 from the 1/2 will give me x to the minus 1/2. That'll be dx. Then I'm going to solve for dx. Try to convert this integral into one involving the variable u. So I'm going to multiply by x to the 1/2. That's going to cancel this x to the negative 1/2. And I'm also going to multiply by a negative 2. So this will be a negative 2 over here, x to the 1/2 du, and then this will be dx. So in that integral, dx can be replaced by this. And I'm also going to use the fact that, okay, from this substitution here, bringing this over to the other side, we can see that the square root of x, and take the u over, can be written as 1 minus u. So let's do the transformation now. This is equal to the square root, and then 1 minus the square root of x under this radical here, the big one here. That's going to be u, and then it's u to the 1/2. Instead of a square root, I'm going to write a 1/2. So this is u here, and then I got the square root, so that's to the 1/2 power. And then over here, dx is replaced by, so I'm going to have a du, place in the dx, and then I got a minus 2. I'll put the minus 2 out in front. And then I've got an x to the 1/2. I'm going to write that as the 1 minus u. That's the square root. Okay, x to the 1/2 from this substitution here, 1 minus u. So I'm going to write 1 minus u here. And if you used a different substitution and got it to work out, go ahead and post what you substituted for in the comments. So for this one, I have negative 2 integral of 1 minus u times u to the 1/2 du. So this is going to give me negative 2 integral, and this is multiplied through by the u to the 1/2 here. This is a 1/2 here. Same thing as the square root of u. So multiplying through, u to the 1/2 times 1 is u to the 1/2. And then it's a minus u to the 1/2 times a minus u. Add the exponents, 1 and 1/2. That's 3/2. This is du. So now we just integrate with respect to u. Power rule for integrals here. So adding 1/2 to this exponent here will give me u. Or I should say adding 1 to the 1/2 here will give me 3/2. And then dividing the coefficient by 3/2 gives me 2/3. And then it's minus. Again, adding 1 to here, in this case 3/2, we get 5/2. Divide the coefficient, in this case it's a minus 1 by 5/2, it gives me 2/5. And then I got the constant of integration. And that's pretty much it, other than going back to the original variable here. So what we'll do then is replace the u by 1 minus radical x. It multiplied by the minus 2. So this will give me then minus 2 times 2/3 would be a minus 4/3. And then replacing the u by 1 minus the square root of x, and that's to the 3/2 power there, and it's minus here. X will be a plus, minus 2 times a minus 2/3, this will be a plus. Multiply here, 4/3, or 4/5 I should say. And then u to the 5/2, replace the u by, again, 1 minus the square root of x, and the power of this is 5/2, plus the constant of integration. So final answer here, minus 5/3, 1 minus square root of x taken to the 3/2 power, plus 4/5 times 1 minus square root of x taken to the 5/2 power, plus the constant of integration. Thanks for watching, and we'll see you next time.